I like to start off the modules with daylighting because it's one of the points of engagement with architecture students and architects. So we'll start with natural lighting, and as we move through the subject matter, we'll move to artificial lighting. And the idea here is for environmental controls. There are issues with natural lighting providing well-illuminated work surfaces, and when we don't have natural lighting available, the idea of augmenting that with other types of artificial lighting systems. So obviously the most attractive point or engaging point for architects is that natural lighting really creates a great sense of quality into your spaces. And there are some justifiable, I guess, business arguments or workplace arguments to be made for the inclusion of natural lighting in our environments. In many cited times, or many references that are cited include this idea of health and well-being, people healing faster in therapeutic environments, providing access to the view gives people a general sense of at ease or comfort with their place, their location, if they're in touch with what's happening on the exterior in the natural environment. And it doesn't have to just be green space. It can be just connection to the urban street facade, seeing cars pass by. So I'm using one that's depicting a bucolic scene of a natural environment, but obviously this could also be an urban setting. And there are a lot of justifications that this kind of connection and natural lighting increases productivity, enhances healing, is a better learning environment. But I would caution you to make sure you can back that up with some research that you may have done. You can start with Google and move into some journal and published literature about the kind of enhancements that happen here. So with that said, there's all kinds of other nice resources. This is a hyperlink document about how daylighting, and it's an architecturally oriented one, about how daylighting can make your design more sustainable. So this is hyperlinked. If you click out to it, it will take you to that site. And it's got some nice sketches to punctuate the concepts of what lighting can do in architecture, excuse me. So, but with that said, before we move into artificial lighting, I'm going to go through a bunch of different techniques for bringing natural light into the built environment. And I'd like to, connect this to, this is not obviously a new concept. And many of the best architects that we know of have always thought about natural light as being one of the principal components of the built environment. And this is Louis Kahn. A room is not a room without natural light. A master at playing with light on interior spaces and all the wonderful things that come from that, and whether it be revealing textures and massings in buildings. So I don't know if I have any of these hyperlinked. But this will be part of your history education also. So here's a nice graphic that just kind of describes this way of introducing natural light into buildings that aren't just limited to front window fenestration systems. So here we have this idea of a light well, roof monitors, light shelves. This is an exterior window, but this idea of reflecting off of surfaces to drive light deeper into the building. The light well, when covered, becomes an atrium. This is a little more on the fringes of anything I've ever seen. This idea of a light duct, the idea of reflecting light deep into the building. Clear story, a really common effect. That's actually what we're seeing in this kind of effect here. It's a clear story lighting. The light being reflected off of these surfaces and driven down into the interior spaces. And then there's other kinds of controls with blind systems and baguettes to reflect light deeper into the building. So This is where we can make reference to our textbook. This is a graphic out of that that describes that idea of a clear story window. I think when you think about clear story, think about something that isn't a vision level, so it's above the height of the occupant of the space, and it brings illumination in above. I think this is a great graphic of that idea, what you can do with bringing light in and still maintaining privacy. And in this case, the idea of the clear story and bringing light in allows privacy for what this appears to be, could be a dressing room or a locker room. So there are many applications where you may want to bring light in without losing privacy, so to speak. And here's a nice mix of that idea of clear story. And it kind of, I thought this was a good graphic because this is also dealing with this idea of privacy. So here we have actually a comparison here. We have frosted glass, translucent glass, and I'll describe, those properties there. Gives us privacy, but lots of illumination. We're bringing lots of light in through clear story, so we have a lot of privacy to this side of the building. And it looks like they have other things to obscure the view through, with plantings or whatever on this side of the building. So there was a lot of thought. It looks like this could be an optometrist space or some kind of a showroom. And so there was probably a lot of interest in working or meeting with clients. So here's that idea of translucency. I'll go back to this image. It's white panels back here. So we have this idea of opaque, and this is white. This could easily be black. There's absolutely no light transmission here, and we all know what transparent is. But with this idea of translucency, we have all kinds of ways that we can control the amount of translucency and therefore the amount of privacy and also the amount of solar light that gets transmitted through our panels. So these are some key words that have been identified in this course: transparent, translucent, and opaque. So here's on that idea of translucency, here's a technical CalWall product that is a fiberglass reinforced polymer, basically a translucent glass-like material, except it's not made out of glass, it's now made out of fiberglass. Very popular to create both an insulated wall surface. It's insulated because there's these air pockets that get formed within the interstitial layers of the material, whether it be this extruded plastic. This is not CalWall, but another similar kind of product. But that creates a sense of insulation, but it still allows for the transmission of light. And you can see, and this is an application of that, where we are controlling the areas that we can see through and the areas that we don't want to see through. Once again, another technique of daylighting, just a standard window, but in this case, back to our mechanical, our MEP book, this idea of window placement and then using surfaces to help drive light into the space. So here we have a window that could have been placed in the middle of the space, but now it's offset against a wall. In this case, the interior designer chose to actually double up on the quality of the light that was being delivered here by putting a reflective surface in. But nonetheless, that can also just be the wall itself to reflect the light off coming from an obtuse angle or through the window system, and using the wall as a reflector to drive light into the space. And here's a really nice example, I think, of that. Now we no longer have the mirror here, but we have this this idea of the window right next to the wall, reflecting the light in, and then really this nice extra play of shadow created by the blinds or baguettes that are on the exterior window covering. Another classic discussion that we go through with daylighting is actually the control of it. Obviously in summer, we want to cut down on the amount of solar gain, the heat from the sun. Yeah, anyone who's sat out in the sun in an automobile with the windows rolled up realizes the intense amount of energy that comes from the sun. As architects, we have a lot of control over that as far as time of year. So in the summer, the sun is really high in the sky. We'll learn more about that as we move through the program. And in winter, it's low in the sky. So we can actually create light shelves, exterior shelves that will protect the opening from direct sunlight and the associated heat gain and glare that might come from that. This was another interesting illustration out of the book. This is the idea of using a splaying of the window opening. I really had never personally given much thought to this or the effect of it, and I found this image I thought was, quite interesting. You can see how it's a small window, but the opening has been splayed out wider. And the remarkable thing here is that this is not now just a little black hole with a window in it, because you can see this front surface over here is really dark because it's not catching light. But by splaying these openings, you can actually create a much lighter surface around the window and kind of help to reduce that idea of the contrast between the opening and the interior wall surface, and then also create reflective surfaces to help drive that light deeper into the building. Here's the idea of a light well, kind of a version of a clear story, but now we're using a couple of elements to just really do some nice things with the lighting. The lighting now just cascades down the wall surface. This other solid surface here is really kind of blocking light in here, so we get this very interesting illumination of the floor. But this could be used in as a way of controlling light where you don't want it to, enter. So you could see this as being the entry to a theater, where you want to have some daylighting as people come out, but you don't want it to be too intense if they've been in a dark area. So it's a nice way to create a transition between the outside and the inside that gives you enough illumination, but drastically reduced before you enter the dark theater, so your eyes can become acclimated. And that idea of acclimating your eyesight, we should all know that your eyes create, I guess it's called a visual purple. They become more light sensitive as the lighting level gets lower. They create chemicals that allow your eyes to see, and it takes a certain amount of time for that production of the visual purple before we're fully light adapted. And going the other direction, when you're leaving a dark area into a bright area, that sense of overwhelming brightness, and that's the process of that, of actually having to destroy that visual purple and reduce your eye sensitivity to light. So there's a need for that in both directions. So I'm going to break this right now. That was all just a brief introduction to natural lighting, and we'll pick it up again in another mini lecture.